Okay, so we have taken this file which is downloaded from sample captures, and it is a AAA.pcap. This is a file we have downloaded. You can search that right here, or this is from the zip file. Here it is, zip and RTP, which is available here. And this is the first file itself, AAA.pcap. This is the one I have downloaded. And we will be doing a challenge here. Need to using display filters effectively, we should be able to get these answers for these questions. First one is how many zip packets are there. There are multiple ways to solve this one. You can go here and type simply zip, which means contains anything that has a, that is a zip protocol. And come here, see how many are there. 81 packets, zip packets. Or you can go to telephony. So the thing is that we are learning display filter, so we would not be using telephony here, but you can go here, go to the zip statistics, and there you can see a lot of statistics. So how many are there? See, count. How many are there with the trying? How many are there with the let's say with a particular status code? So we can see all those details here and zip statistics. So how many packets are there? These can be either requests or replies. So 81 packets are there. And that is the answer for the first question. And here also go to the statistics and protocol. So, and also we can other one you can use here is for any kind of other information that we are trying to get. So we can also use IPv4 and IPv6 statistics to find all other addresses, all endpoints. Okay, now let's go. We got the answer for the first one, which is 81. Now, what is the second question? In a 21st frame, what are the 2 bytes of the payload, UDP payload? Zoom. Okay. So what do I need? I need a 21st frame. You may go here from 1, 2, 3. So you need, see here it is not sorted by like that. Sorted like yeah. See, sometimes it might be you need to make sure that it is displaying 100% when you are actually doing anything from you are trying to write a display filter flashly. So make sure it is 100%. If it is not 100%, just remove the display filter and hit enter. So 21st frame. So you can go to the 21st frame like this, or you can scroll and go to the specific frame you need. But thing is that might be time consuming stuff. So if you want to jump directly to any particular frame, we have the expression for that also, which is the frame dot number equal to 21st. It will filter everything and will give you that particular frame. There you can go to the what is this? Here it is, UDP protocol. It is a UDP payload, or which is a data from the upper layer. DNS protocol that is encapsulated into UDP payload. You can see here. And what are the first 2 bytes? You can see there, 38, P3. These two are first 2 bytes in the UDP payload. The next question is how many zip replies are there with the status code 100 trying. So I need to clear first this filter. So you can click this one to clear. Cross mark here, and 100% is display. What I can do, I can go to analyze display filter expression. Okay, and so you can go on looking for the field you want, or search zip dot. You can see here Or what is the question? Question is replies with the 100 trying, which is the status code. See, expand this one, and do you see here? This way you can filter down, you can narrow down what you are looking. Here is the SIP status code. And or if you want, just filter the SIP, go to the SIP protocol, and there are a lot of fields out there. Okay. Here is the SIP status code, which is 100 trying. The value is 100. Then here you can see if it is a green, which means that a valid expression. If it is a red, which is invalid expression. Now hit enter. And how many are there? 7. Okay. 7. Seven are there. Okay. Okay, what is the fourth one? SIP replies with status 403. Status code 403. How many are there? See, another way to do this one is you don't have to go to the display filter. So you can actually try here. SIP dot status code equal to 403. How many are there? 3. Okay. And the what is the IPv4 header checksum in a frame 180? Again, so you can filter the frame by frame dot number 180, right? And what is asked? IPv4 header checksum. IPv4 header checksum. Where is IPv4? Here. This is IPv4. And where is the checksum? Here it is. You can copy. If you want, you can copy the value, which is a 16222 hexadecimal number, which is. And now, how many packets are there with the greater than? How many packets are there with the UDP or with the length? How many UDP packets are there with length greater than 512? What you can do, you can go to filter expression. There is a better way even. What you are looking for, you are looking for the UDP, and what you are looking, length. And you can right click here. So go to that field directly, and you want to filter based on this field. Right click this one. There, apply as a filter or prepare as a filter. Apply as a filter will run the filter, will filter the expression and will run that filter. Prepare as a filter will prepare, but it will not run. Okay. So apply as a filter, selected. Okay. So it gave me like packets with length 688. But I have to modify that because you know how to write expressions. I want greater than, so change 688 with a 500. So this way, you can quickly jump. You can if you come across the field and if you want to quickly filter something based on that field and right click right there and prepare the expression. Now you can see how many packets are there. 28. So how? Am I counting these packets here? No. Here I am looking. Now status bar 28. Right? Okay. Now, so what is the answer for this one? IPv4 packets with time to live less than 64. Okay. So, and I just write another one, combining 7 and 8. Okay, sorry, 6 and 8. 6 and 7. I want the next 8 question to be packets which are greater than UDP packets of length greater than 512 and time to live less than 64. Okay, now, so that time to live, I can go to filter, I can go here, statistics and construct, analyze filter expression, display filter expression. There I can construct, but here is the IPv4 and here is the field, you know where it is, and right click there and prepare as a filter, selected. See, I selected that, I got that, but it didn't apply that filter because when you prepare the filter, it doesn't run the filter. Simply prepares the expression and will put that expression there in this display filter box. So you have to hit enter to filter. So how many are there? So which is 180, but I have to modify this. What is the question? Which is less than 64. How many are there? 64 packets. Which is such a coincidence. We have 64. Answer is also 64. Okay. So now it is combining 6 and 8, 6 and 7. What does it mean? Here, I want packets, which means I want packets, UDP packets greater than 512 and or with, okay, TTL, IPv4 TTL less than 6. I want these two things. I want a package that satisfy these both conditions. In such a case, what I can do, I can apply, go to the UDP and right click, here is the length, right click, and there apply as a filter or prepare as a filter. When do you use a prepare as a filter? Because if you want to modify that filter, in such a case, prepare as a filter is helpful. Apply will run that filter that is prepared immediately. So here is a and or not. These expressions are here. You can combine using these logical operators. Now what I want and selected. So this modified the filter. You can see here I didn't run. I haven't used the apply as a filter. Instead I used the prepare as a filter. So now you can come here and select udp.length. It is not 948, which is a greater than 512. Okay, so how many are there? So don't count these packets here. Here is the answer, 7. Right? How many SIP are there? 81. Okay, how many? What is the UDP payload of, what is the 2 bytes of the UDP payload of frame 20, 38. Okay. So I hope this is helpful. This is how you can work smart with the Wireshark.